Hi everyone. In the last session, we have seen the difference between the structure and the union. We discussed that the main important point to remember between the structure and union is memory allocation. In the structure, whenever we create a structured variable, the memory is allocated to the structure members individually. And the amount of memory taken by the structured variable is nothing but the total amount of memory which is allocated to all data members in a structure. Whereas in union, the memory is not allocated to individual data members. The memory is allocated to only the largest data member. That means all the remaining data members, including the large data member, are going to share the same memory location. One memory location, or I can say one largest memory location, can be shared by all the data members in union. And we have discussed that a structure is created using the keyword struct and union is created using the keyword union. And the memory is wasted in the structure, but the memory is not wasted in the union variable. That we have discussed in the last session. In continuation of the last session, today we are going to discuss some important gate examination questions on unions. Let us discuss. The first question we are going to discuss here is this. Here we have given a structure. Here the name of the structure is not mentioned. This is a structure without name or without the structure tag. This is known as anonymous structure. Without using the structure tag also we can create a structure. This is the outer structure and the structured variable here is t. And within the structure, outer structure, we have the variable short s of 5. In the gate examination, they have given this code and they have mentioned that short is going to take 2 bytes of memory, and next float takes 4 bytes of memory, and long takes 8 bytes. These are the details which were given in the question, and they have said that there are no memory alignment consideration, no memory alignment considerations. What does it mean? That means here we are not going to use the concept of padding. There is no padding. That means we are using this hash pragma pack 1. Means without considering the padding, they have asked what is the amount of memory allocated for the variable t. What is the total amount of memory allocated for the variable t? That is the question. Now, how to find out the memory, how much calculated to the variable t? Now, inside the structure, we have created a variable s of 5, means it is an array of structures s of 5. That means we have s of 0, s of 1, and s of 2, s of 3, and s of 4. These are the 4 structured variables, right? Each structured variable is going to take 2 bytes of memory. Why? Because here we have given that in the question short takes how many bytes? 2 bytes. Short means short integer. Here 2 bytes, 2 bytes, 2 bytes, 2 bytes, 2 bytes. Total how much? 5 into 2. Total 10 bytes of memory is allocated for the variable s. Here we got 10 bytes. Now within the union, we have created a variable called u. The amount of memory allocated for the t we are calculating. First, we are calculating the amount of memory allocated for the variable s. How much? 10 bytes. After that, next we are taking the union variable. Here it is the short integer variable s, and next the union variable is u. For the union variable u, how much memory is allocated? As we discussed in the previous classes, in the union, the memory is allocated is represented, or the amount of memory allocated for the variable u is nothing but the amount of memory taken by the largest data member. Here we have the variable y, how much it takes 4 bytes, and here we have long variable, it takes how many bytes? 8 bytes. 4 bytes and 8 bytes. Out of these two members, what happened? We are going to use only one memory location whose size is 8 bytes. That means we are not going to create separate memory locations for y and z. We are going to create only one memory location. This is shared by both y and z. The amount of memory for this is 8 bytes. So for the variable u, or for the union variable u, the amount of memory allocated is 8. Now, total amount of memory allocated for the variable t is given as 10 bytes plus 8 bytes. So here the answer is 18 bytes. Now, the amount of memory allocated for the variable t without considering any padding is 18 bytes. This is the answer, right? Now, after this, we are going to see the applications of union. Next, we will discuss the important point, applications of unions. Let us discuss the applications of unions. Let us take an example of store. The store is going to store the information about two items. The first item is about books and second one is about shirts. That means book information and second one is shirt information. See, generally a book information consisting of first one, the name of the book, book name, or we can say the title of the book, and second one is author name, or simply we write author, and third one is pages, number of pages, and fourth one price. These are the four important properties or characteristics of a book to store the information regarding the book. Similarly, you take item shirt. The shirt consists of the color of the shirt, and second one is the size of the shirt, and third one we are talking about the design of the shirt, and fourth one we are talking about the price. C for the book, the related information is about how many things? Four. Here also we have four. But if you observe the information, the characteristics of the book and characteristics of the shirt, the common field name is price here. Now, how to create a structure that is going to contain the information about the book as well as the shirt? See, to store this information, let us create a structure. For example, here I am writing struct, and the name of the structure here we are writing it as store. Now, what are the fields we have? The first field we are having book name, B name. You can take as a character array or you can take a character pointer. Here we are taking character book name. And next one is character author, name of the author. So next we are taking the second member is also of character pointer. After that, integer, and here we are taking the pages. Next, float, or you can use any double. The price we are taking here, price. So these are the four data members which are related to the book. But the store also going to store the information about the shirt. Now we have to store the shirt information also. Character. Here we are mentioning the color of the shirt. Next character, size of the shirt, and next we have character star design, character star color, character star size. Generally you can take size of type character or integer. Size is integer, right? You can take the size instead of taking character, you can take it as integer size. Okay, I'm taking size as of type integer and character design. So these are the important properties of the store. Now when and structure ends with the semicolon, here I'm writing the semicolon, right? Now in this case, we have taken the information about the book as well as the shirt, book name, author, pages, next color, size, design. Here the price is common for both the book as well as the structure. So that's why I have taken only one time. Now after creating this structure, next we are starting from the main, integer main and opening brace. Here what I'm going to do is I'm going to create a variable like struct store, and I'm taking the variable called book. I'm taking the variable as book. Struct store book, comma, or assume that semicolon. In the next line again I'm going to create struct store. I'm using the variable shirt. I'm using two variables. One is book, another one is shirt. That means I have created the structured variable book and structured variable shirt. Now, how to access these members of the store using book. Now the items of the store can be created like this. Now book dot bname is equals to, we are writing as, for example, C programming, right? Next, book dot author equals to, here we are writing Balaguru Swami, right? Balaguru Swami something here. Next, book dot pages, here we are giving, assume that 180 pages. Next, book dot price is equals to, book dot price is equals to 205 rupees. So we are using the book information, we are storing the book information. So for the book, we have used these properties. And next, similarly, you can use the variable shirt. We can say shirt dot color is equals to some red. Okay. Next, we can say shirt dot size equals to, you can say the value 42. Shirt dot design equals to some checks like this. We are using this. See, the thing here is, whenever you create a variable book, the structured variable book, for this, what happened? The related fields for the book are book name, author, pages, and price. These four. But the thing is, whenever we have created a book variable, then along with the memory allocated for the book name, author, pages, and price, this book structured variable also going to take the memory for the color, size, design. Though these three properties are not useful for the book. Means the amount of memory allocated for the color is character pointer. That means it is going to take 8 bytes. Next, size, integer takes 4 bytes. And design, again character pointer, it is going to take 8 bytes. Total how much? 20 bytes of memory is unnecessarily allocated for the variable book. Though we are using only book name, author, and pages here, and price. This is the extra amount of memory, 20 bytes, which is allocated to the variable for book. In similar way, whenever you create the variable shirt, for the shirt, the required fields are price, color, size, design. So along with these four properties, the shirt also going to take the amount of memory allocated for the book name, author, pages. So means book structured variable is going to take extra 20 bytes of memory unnecessarily. At the same time, the shirt variable is going to take 8 bytes for the book name, author 8 bytes, pages 4 bytes. So 20 bytes here. Here also 20 bytes of memory is unnecessarily allocated for the shirt variable, though shirt is not using book name, author, pages. So here the memory is wasted when you use the concept of structure. That is the drawback of using structures. So when we use book, it's not using the color, size, and design properties. When we use shirt, it's not using book name, author, pages. So instead of wasting the memory, so we want to store only the required information whenever a variable is created. For that, we are going to use the concept of the union that we will see next. Now we are going to see how to implement the application of unions to reduce the wastage of memory. Take a structure variable, struct, the name of the structure here we are writing is store. Now opening brace, here you do one thing. You take the common property here, float. What is the common property or characteristic? Price. Right? After this, you take a variable union. Within this union, float price. After that, you take a union variable. Now within the union, what I'm going to do is I'm going to create a variable called struct book, and here within the struct book, what I'm going to do is I'm going to take character, book name, next character, author, integer, what do you say, pages, and closing brace, and you end with semicolon. This is the structure of book. Now after this, you take another structure, struct. The name of the structure here is shirt, opening brace. Here I am taking character star color, Next variable I'm taking is integer size. Next character star design, and here I'm going to close this. This is the shirt structure variable, and this is the book structure variable, right? Now after this we are closing the semicolon, and here we are going to close the union variable, right? After closing the union variable, next I'm going to close the structure variable. This is the end of the structure store. This is the end of the union, and these are the internal structures book and shirt of the union. Now the amount of memory allocated for the variable struct to store is how much? For example, assume that here we are creating the variable s. S is the structured variable of store. Now how much amount of memory is allocated for the variable s now? The amount of memory allocated for the structured variable s is given as, so first we are taking price float, how many bytes? 4 bytes. Now this is about the first data member. Now take the union. In the union internally, how many members are there? How many data types? 2 data types. One is book and another one is shared. The amount of memory allocated for the book is how much? C, for the book, character star means character pointer takes 8 bytes, next 8 bytes author, and 4 bytes per pages. How much? 20 bytes here. Now for shared, 8 bytes, integer takes 4 bytes, here 8 bytes. Total 16 plus here also 20 bytes. See, book is taking 20 bytes and here shirt is taking 20 bytes. So among these two structured variables, book and shirt, which is the largest one? Both are having same number of bytes, so it is going to take only one thing, either 20 bytes of this or 20 bytes of this. So total only it takes only 120 bytes of memory. Okay. Now the amount of memory allocated for the store variable s here is 24 bytes. If there is no concept of union, if you create only structured variable, individually the memory is allocated. That means total amount of memory allocated, if you don't use the concept of union, is 4 bytes and 20 bytes for the structure variable book and 20 bytes for the union variable. Total 44 bytes of memory is allocated. Out of 44 bytes, just we are going to use 24 bytes, means 20 bytes of memory is we have saved. That is the main application of using unions. So we are using unions inside a structure. This is the very, very important application of unions. With this, I'm going to wind up the session. Thank you for watching.